this video, we're going to continue looking at the enVision's Algebra 2 topic 5-6, inverse relations and how to find them. So in this one, we're going to find an equation of an inverse function, and the function given is f of x is equal to the square root of x minus 2. So what I'm going to do is, one, I'm going to kind of draw a general graph of this, just so we could get a little bit of a visual of what could be happening. Move that over here, draw the graph off to the side. Doop-a-doo. You guys get my doop-a-doos still? And now that just silence, I go doop-a-doo and then I stop. I start focusing on drawing that line and getting that line a little bit straighter. And what we're looking at is this has a horizontal translation right 2. So let's say this is 2. And it's going to be just like the parent function, just moved over 2. So it looks something like that. That's the general form. Remember that when we take the inverse of this, we're going to mirror it across the y equals x line. So really what we should theoretically see is something here that's, I want to get orange, something here that's 2, and if I mirror this right, it'll look something like that. All right, so we know that our domain here is going to be 2 to infinity. So my domain, again, I want that yellow, it's just not clicking like I want it to. My domain is going to be x is greater than or equal to 2, and my range is going to be y greater than or equal to 2, like I said 2, 0. In my mind I thought 0, and then I was looking up at that 2, and because I saw the 2, I said 2. All right, so which means, so if my x's and my y's switch, that means my domains switch. So my y, or my range, is going to be my domain. So y greater than or equal to 2, and my domain here is x greater than or equal to 0. So there we go. Back to yellow. Let's find this algebraically. Now we know what it kind of looks like, what our function should be, and if I'm looking at this, my function almost displays an exponential function. If you've ever looked at an exponential function in the past, especially in your science classes, they just grow pretty rapidly, and they continuously growing rapidly, with each point being like double or triple the last point. So I have a suspicion that this might be an exponential graph. So the next thing I'm going to do is I'm going to follow the steps. Step 1, change f of x to y. So y equals the root of x minus 2. Step 2, switch your x's and your y's. So here I have x equals the root of y minus 2. All right, now we have to isolate our y because y is our dependent variable, and you always have to isolate your dependent variable when you're graphing. So I'm going to first take the square of both sides. So we have x squared, so I could eliminate the operation of the square roots. We have y minus 2. Now I'm just going to add 2 to both sides, and I get x squared plus 2 equals y. Well, here's the problem with this. My domain is greater than or equal to 0, but if you've looked at this function here, we know that a quadratic has a domain of all real numbers. So the inverse function, we will have to actually say that the inverse function, f of -1 of x, is equal to x squared plus 2 when x is greater or equal to 0. We need to now define that, because if we do not define that, we don't have a true inverse function. So you can verify this again on the graph. We could graph this out. We'll see that we do have the same graph. And the graphs of f and f to the negative 1 are both functions, are reflections over the y and x, and have the same domain versus range. All right, so make sure that when you're looking at this, that you're looking at all the parts. Because again, x squared plus 2 has a domain of all real numbers, but our inverse itself does not have a domain of all real numbers. So a common error is don't apply the f negative 1 notation too quickly. This notation is only used when the inverse function is an actual function, and an actual function is a one-to-one relationship. You put one value in, you only get one value out. All right, so let's look at another example. Let's look at f of x is equal to the cubed root of 4x. And again, I'm just going to draw a general graph. We've seen from previous examples that this is, we could pull out the 4 and a cubed root. I'm actually going to leave it in since I'm not doing any type of values in there. I'm just going to give the general graph shape. Oh, and this is a negative. So negative means we mirror it. So our original one would go from the bottom left up to the upper right. Because this is a mirror and I want to change that color. Oh, that's a horrible start. Okay, so it kind of comes in here. I'm going to draw the middle part first. You guys get to see me struggle drawing this. And it comes up and kind of looks something like this. All right, this is a horizontal stretch. We said that we take that out for the horizontal stretch for vertical stretch, so technically that's a vertical stretch of the cubed root of 4. All right, so looking at this, we do have a one-to-one, one input, one output. My domain here is x. X is all real numbers. My range is y. Y is all real numbers. So we don't have anything to worry about when we write our inverse function because we're looking at all real numbers. And again, we're writing the inverse function about this line. So let's see. I think this would go down. Wait, hold on. It's going to go across like this. I got to try to make this first. And then it will go up. And this one would go down. Something like that. Not exactly the best, but there you go. Again, my drawings are top art. I'm laughing at myself there. All right, so the first thing I'm going to do is substitute y in for f of x. So negative 3, 4x. Okay, then I'm going to switch my x's and my y's. I'm doing this mirroring across the y equals x line. So x equals negative 3, 4y. Now I want to isolate y, so the first thing I'm going to do is, I think I'm just going to multiply by negative 1 to both sides. Take care of this negative, so I get negative x equals the cubed root of 4y. Take the cubed of each side. And here I'm not doing a plus or minus. I'm not, or I guess I'm not doing anything. Never mind, we're going to leave it at negative because it's still negative x cubed. And then I'm going to divide by 4. So my inverse function is going to be f of negative 1 of x. And I actually did draw that incorrectly. It goes the other way. If I was paying attention, because it's a negative, it actually goes this way. Because these are negative, negative, positive. This is positive, negative. But I want to get a rough sketch idea of what this looks like. There we go. So it's more like that. And we get this equal to negative x cubed divided by 4. And I could actually remove those parentheses because it is a odd value, so negative x cubed divided by 4. And that is why I was like, oh, we have to change that. I noticed that this was negative, and I was like, oh, we have to make this the right-hand arrow pointing down for the end behavior. All right, so there we have it. There are finding equations using, they're kind of like putting everything together with the rationals and the radicals and the inverses. I guess we don't have a rational here, but they're trying to put it all together in these last couple of examples for you guys to follow and see what to do and the domain and range and increasing, decreasing, and all those things. But here we go. Here is our final example for topic 5. All right, guys, if you have any questions, please always feel free to ask. Always send me a comment or an email. And again, I always feel like saying hit like and subscribe, and we'll see you in the next video.